Hello students, welcome back. In today's video, we are cracking the code on one of the absolute most important and most tested topics in organic chemistry, that is ring expansion reactions. Whether it is three-membered ring jumping to 4, 4 to 5 or 5 to 6, examiners love to trick you with these in the exam. But don't worry, by the end of this video, you will understand the exact step-by-step mechanism and the hidden driving forces behind these shifts. Make sure to watch until the very end so that you will learn a named reaction based on the ring expansion. So let's get started. In the first question, the reactant molecule is a Spiro compound. What are Spiro compounds? They are bicyclic compounds where we have a quaternary carbon. So this carbon is common for both the rings. Such molecules are called as Spiro compounds. It is also having a functional group, that is alcohol. So it is a Spiro alcohol compound. When it is treated with sulfuric acid under heating conditions, we are getting A as a major product. So what is that major product? So obviously it is a ring expansion. So answer has to be either B, C or D. So let's predict what is the correct structure. For this, start proposing the mechanism. See, whenever we have sulfuric acid, it generates protons, right? And protons are considered as electrophiles because they are positively charged species which are electron deficient. Therefore, they are electrophiles. And what about our alcohols? Alcohols can act as electrophile as well as nucleophile. Then how do you decide whether it will act as electrophile or nucleophile? Check out the reaction conditions. If this is acting as an electrophile, this will act as a nucleophile. So how it will act as a nucleophile? On oxygen, there are two lone pairs of electrons, out of which one lone pair will be given to our electrophile. So what sort of reaction intermediate it is going to form? So observe here, this oxygen donated its lone pair to the hydrogen. So there is a new bond formed between oxygen and hydrogen. Since it is trivalent now, the oxygen will have positive charge. You can think this way also. Neutral molecule accepting positive means the overall charge on the molecule will also be positive. So students, can oxygen have positive charge? No, it's a electronegative element. So what it does, it will take these bonding electrons with it and it will leave as water molecule minus H2O. Now what will happen? Since this carbon lost its electrons to the oxygen, it's going to have a positive charge. So this is where we got the positive charge. So what do you call this reaction intermediate as? Carbocation. Carbocations are the reaction intermediates formed during the course of reactions. Since they are electron deficient, they tend to undergo different shifts, like there is a hydride shift, methyl shift, ethyl shift, and even phenyl shift. Okay, but in this case, since we have a 5-membered ring, so the shift happens in such a way that there is a ring expansion reaction. So how the ring expansion is done? So either this bond or this bond will shift instead of hydride, methyl, ethyl, phenyl, okay? Because no such groups are present on this carbon. So it is forced to shift this bond only. So check out now, this is the one which is shifting. So how to write the structure of the product? Many students fail to identify this step, okay? So let me explain this in detail. See here, we have 4 carbons, CH2, CH2, CH2. You write down that as it is 1, 2, 3, and 4. And this carbon is forming the bond over here, right? So this is a new bond formed like this, right? What happens to this carbon? It lost these bonding electrons, right? Now it becomes carbocation. When a carbocation undergo rearrangement, this is called rearrangement because you see the number of atoms are same. The molecular formula is same, everything is same, but they are different structures, right? So you call such reactions or steps as rearrangement. It undergoes rearrangement, so it will remain positive charge. But this is not the correct representation, isn't it? So let's represent it in a better way. So we have 6-membered ring. You see this and this are attached and they are also forming a 6-membered ring like this. This is again a bicyclo compound. So here it is Spiro, right? So here we call this as fused rings. These are two fused bicyclo compounds. Since there are 10 carbons here, the molecule can remain as planar at this particular position. That's why the stability of this carbocation is possible, because generally we say that the bicyclo compounds are examples for non-classical carbocation, but here since we have 10 carbons, such planar carbocations are very much possible at the bridge carbon. So finally what we have to do, we have to remove the hydrogen, because look at the products, there is a double bond. So how the double bond is formed? By regenerating the catalyst what we used, right? So for that, remove this hydrogen and form the double bond. We are going to get a product wherein the double bond is highly substituted, hence it's going to be more stable, and that is nothing but option C. Let's solve one more ring expansion reaction. So the given molecule is a cyclopentane molecule. Students, the representation of the molecule is not proper here because the carbon-carbon, the single bond is not properly written. So I'm just going to rewrite it like this. Okay. So you have a kind of vinyl group attached to this carbon, right? So here, so when it is treated with hydrogen chloride, what should be the major product? See, in the first reaction, what we did, it was a dehydration reaction because you have converted alcohol to alkane. But here, if you look at the options, we are adding hydrogen chloride to the double bond, and it is happening through ring expansion. So how do we know that? You write down the reaction mechanism. If there is a carbocation formation and there is a possibility that it will undergo ring expansion from 5-member to 6-membered ring. So for that, what we will do, the first step is polarize this molecule H plus Cl minus, and we know that the alkenes are electron rich. Because it is electron rich, it is going to attack the electrophile or electron deficient species. Look at this alkene, it is unsymmetrical. So which rule are we going to use now? Markovnikov's, in order to add the proton across the double bond. So write down this cyclopentane molecule. So the methyl as it is. Look at this. This is the methyl group over here. And the CH2 will become CH3 now. Why so? Because the hydrogen goes to the carbon with more number of hydrogens. Then what happens to this carbon? This carbon will become positive. Why so? A neutral molecule accepting positive, and it is forming positive, and specifically at this particular carbon because it is a tertiary carbocation. Now, the formed carbocation, can it undergo rearrangement? As I told you earlier, it will undergo rearrangement. How so? For that, let's write down the mechanism. So either this bond will get cleaved or this bond will get cleaved. Nothing but the ring expansion is happening. Say suppose when this bond get cleaved and it attacks over here, you are changing from 5 to 6-membered ring. So what I do is, whenever such products must be written, first I will write the 6-membered ring. Okay. Then say if I consider this as the first carbon, I'll mark this as the first carbon. You see on this carbon there is a methyl. So I'll write down that first. Then what I'll do, I'll number the carbons like this. Okay. So if this is first, then this is 2, this is 3, then this is 4, and this is 5. And the 5 is attacking the 6th carbon. So this is our 6th carbon, and the 6th carbon is attached to 2 methyl groups. So you write down those methyl groups. But where should be the carbocation? If it is forming bond through this 5th carbon, right? The first carbon, right? Earlier it was tetravalent, 1, 2, 3, 4. Now it is only trivalent. Therefore, the carbocation must be on this carbon only. The first carbon should have the carbocation. Now what should happen? So you still have chloride in the reaction mixture. So the chloride will attack over here. There is no other rearrangement because this itself is a tertiary carbocation. We know that tertiary carbocation is the most stable. So finally the chloride will attack here. And look at this. The 2 methyl groups are as it is, 1 methyl group is as it is. That's where the chlorine is also attacking. So nothing but we are going to get the product as shown in option C. The final answer is option C. Students, you can solve this by eliminating the bad options. Bad options in the sense, you know that whenever there are 6-membered rings in the option, Definitely a 5-membered ring can expand to 6. In that case, you can eliminate A and B. Check for C and D. We have how many methyl groups here? 1, 2, 3. 1, 2, 3. But here there are only 2. So you can eliminate D. You are left with only C. So definitely you can choose C as the final answer even without writing the reaction mechanism. But if you want to confirm that C is the final answer, of course you can write down the reaction step by step and you can conclude that C is the final answer. Students, in the given example, there is a halo compound given which upon hydrolysis it's forming an alcohol. That means you already know the reactant and product. You need to come up with the proper mechanism to show the ring expansion from 4-membered ring to the 5-membered ring, because you can expect such reaction mechanism questions. So how to solve this question? So understand here the chlorine is being substituted by the hydroxyl group means what? This is a classic example for nucleophilic substitution reaction wherein a carbocation will be formed. Why so? Because the ring expansion or hydride methyl shift happens when there is a carbocation formation. A nucleophilic substitution with carbocation means what? You can say that it is a type of SN1 reaction mechanism. What do you do in SN1 reaction? First, you are going to do the heterolytic fission of the carbon and halogen. So the halogen is electronegative element. So it will take the bonding electrons and it will leave the molecule. So you see here, this is where the carbocation will be formed. So why this carbocation will be formed although it is a secondary carbocation? Because the driving force for this reaction is a 5-membered ring is more stable than a 4-membered ring. In 4-membered rings, there is an angle strain in the molecules, so they are not stable. The 5-membered rings, the angle strain is somewhat reduced. Hence, they are considered to be more stable. So this is the driving force. Now what should happen? There should be a ring expansion. How the ring expansion happens? Either this bond or this bond will shift. So I'll use this bond which is going to shift like this. So how to predict the product? I'll give you a simple trick. Start numbering the carbon atoms like this 1, 2, 3, 4, right? So when the ring expands over here, this carbon will become part of the ring. So call this as the 5th. Okay. So you write down a 5-membered ring like this. Now, you can randomly number this, okay? 1, 2, 3, 4, and 5. At the 4th carbon, you see there is a methyl group, okay? So when the ring expands here, on the 5th carbon, you see there is one more methyl like this. And where should be the carbocation? Look at this. When the bond goes like this, 4th carbon is the one which is electron deficient like this, right? So this is a tertiary carbocation and tertiary carbocations are pretty stable. No further rearrangement. So you can see there is water in the reaction medium as a nucleophile. So the water as a nucleophile will attack our tertiary carbocation. Further, by removing the proton, what product are we going to get? A tertiary alcohol like this. And look at this structure. It's nothing but what we got after writing the reaction mechanism. So what sort of multiple choice questions you can expect from here? The formation of a carbocation or what is the order of the reaction? Such questions can be asked from this particular example. Students, this is the bonus question I was referring to you earlier regarding a ring expansion reaction, which is also a named reaction called Buchner ring expansion reaction. So here we are going to expand a 6-membered ring to a 7-membered ring. But this is different than rest of the molecules what we have discussed so far because this molecule is aromatic in nature. Earlier, whatever the molecules we have used, they were alicyclic molecules. So when benzene is treated with ester, which is also a diazo compound, in presence of metal catalyst or heating condition or a photochemical reaction will give us highly strained 3-membered and a 6-membered fused complex molecule, and this is not stable. So what it does, it will undergo ring expansion in a concerted mechanism to form a 7-membered cyclic molecule. But how is this happening? So let's predict what is the mechanism of Buchner ring expansion reaction. So whenever we see such molecule, we should know that it's going to form a reaction intermediate called as carbene, because carbene tend to undergo addition with the aromatic molecules like benzene. So let's write down the benzene molecule as it is. Okay, so this is going to form a carbene. Carbene is a reaction intermediate where the carbon is having 2 electrons like this, and it is divalent and it will have 6 electrons around the carbon. So we consider it as electron deficient species. And we know that benzene is electron rich. So what happens now? You can see that this double bond will get added to this. It's a kind of a double free radical. It will add to the benzene ring. It could be the concerted mechanism, one step also. And you see, this is where the bond is formed. And this is a carbon which is attached to hydrogen and an ester, COOET, like this. This is exactly what we have written here, and you can even give the name of the molecule as a bicyclo. You see there are 4 carbons here, 4, and there is 1 carbon. Since it is bridged, there are no carbons between these two, therefore 4.1.0, and there is a heptadiene. Of course, it is a derivative of an ester. We are just naming this molecule. This molecule is not stable. Why so? You see, this is a 3-membered ring. 3-membered rings are highly strained molecule due to ring strain. There is a huge deviation in the bond angle. So what happens? It wants to become free. So how this will become free? By concerted mechanism. So whenever we like this, they are reversible. All right. So you see, it will go here, this sigma bond will shift here and the pi electrons will shift here, the pi electrons will shift here. So such reactions are also called as pericyclic reactions. In pericyclic reactions, you can see such concerted steps wherein there will be a ring opening or ring closing reactions. See here, there is a ring opening now. This ring is being opened. So once it opened, we are going to get a 7-membered ring like this. So assuming this is the carbon we have here, right? It is attached to H and the ester COOET. And you see the bond here, it is in conjugation. Double, single, double, single, double. So that's what we have here. We can call this as cycloheptatriene molecule, which is stable as compared to a fused 3 and 6-membered ring. So this is the mechanism for the Buchner ring expansion reaction, where we have the important reaction intermediate carbon and also a pericyclic reaction, which is a one-step concerted reaction. Students, this reaction is very important for your JEE Advanced exam. So this is the last question of this video. So what I'm going to do is I will give you enough hints to solve this question so that you can come up with the right answer on your own. What is the reactant molecule here? It's a cyclopentane molecule wherein there is a exocyclic double bond and we also have 2 methyl groups attached to the carbon. So it is treated with an acid. It is forming a major product A, which can also revert to the reactant. So what should be the structure of molecule A now? First, you add the electrophile to the double bond so that you're going to get a carbocation. And this carbocation will undergo rearrangement. There is a breaking and making of new bonds so that you are going to get a 6-membered ring. How do you know that? Look at the options. All the options have 6-membered ring. So predict what will be the structure of the 6-membered ring and then remove the catalyst, whatever we have added here, so that you are going to get the alkene again, because all of the products do have a double bond in them. So use all these clues and then find the correct structure of the final product A and comment your answers to know the key answer. I hope I have helped you with this important topic from organic chemistry. If you still have any question, please do ask your queries in the comment section. And don't forget to like, share and subscribe my channel. Thank you.